Two was a concept that was taught to you early on in the year in August when I was gone. How do we find the inverse of a function? We also practiced finding the inverse when we did AZ merit practice. Well, here's how we do it. Where we see the f of x, g of x, h of x, we're going to change that initially into a y. The next step will be to switch the x and y. So here is my function. I'm going to switch the x and y. And the last step will be to isolate the y. So I'm going to subtract 7 from both sides. And now to isolate the y, I will need to eliminate the square. So I'm going to take the square root of both sides. And y equals the square root of x subtract 7. Now how do I identify this as the inverse of this original function? We do that by making this little inverse symbol. The inverse of f of x is the square root of x subtract 7. Part B says take this answer, okay, so I'm going to come up above here. Take this answer, which is the inverse of x, inverse of f of x is the square root of x minus 7. Take that answer and tell me the domain. Well, I personally like to have something graphed before I tell the domain. Some of you are really good at just visualizing this in your mind. So let's use this part C to do that. Let's graph this function. Okay, so here we go. You ready? Let's make a little table. It is a square root. 0, 0, 1, 1, 4, 2. Now, before I graph that, which way are you going to shift this? To the right 7. So I'm going to go to the right 7. So to the right 7, I'm not going up or down. There's no vertical shift to this. So just go to the right 7. Okay, that's your new 0, 0. Then you're going to go over 1, up 1, and over 4, up 2. This is the inverse of f. Now here's the cool part. If you've forgotten this from August, let's write these points down right now. So let's write these points down. We have the point 7, 0, 7, 0. Then we have 8, 1. Please do the same. And here's 8, 9, 10, 11, 2. Okay, those are the 3 points. Part C, so we're going to come back and talk about the domain. I should do that before I finish part C. What is the domain of this function? Well, at what x value does it start? It starts at an x value of 7. Do we include 7? Is there a closed dot at that point? So we start at 7. There's no limit how far it goes to the right. Now to come back and finish out part C, we want to graph the original equation. Look back at part A, and I'm going to write it down. It says f of x equals x squared plus 7, but they only want to graph it where x's are greater than or equal to 0. Grab your calculator, please. Please do second plus 7, 1, 2. We're going to plug this in. So in parentheses, I'm going to write x squared plus 7. Okay, now I want to get to the table. Do second, which is in this position, and table. Second, table. Why am I doing that? Because the directions here say I only want x values for this function that are greater than 0. And there is a line underneath, so that means greater than or equal to. So let's start at 0. What does 0 correspond to? 0, 7. So let's graph 0, 7. 0, 7 is right here. I'm also going to come off to the side and write 0, 7. What's the next number? It is 1, 8. 1, 8 is next. So go over 1 and up 8. I'm going to write that ordered pair off to the side. And the last one is 2, 11. 2, 11 is less. I'm going over 2, I'm estimating. Here's 9, 10, 11, 2, 11. Then I'm going to hit graph, and I know I'm only doing it where the x's are greater than or equal to 0. So I'm looking at this part right here. Okay? I'm like, hey, mine does look like that. I have completed part C. Let's analyze for a second our ordered pairs. Look at the ordered pairs. Do you see a relationship? What is the relationship? Turn to your partner, go. Okay, here's the original function f of x. Here's the inverse of the function. I can see that the original function, the x value now becomes, it's like they've swapped places. The x value becomes the y value, and the y value becomes the x value. X value becomes y, y becomes x. Does everybody see the difference here? Okay? So down below, you could describe that. I want you to do one more thing. I want you to take a pen, and I want you to do this. 0, 0, 1, 1, 2, 2, 3, 3. If you have forgotten, there's one other relationship that we can talk about on this graph. If I asked you to fold, and you can do that with a pen. You didn't have to use a highlighter. If I asked you to fold along the green dot I have, this is the line y equals x. What would happen to these two pieces if you folded directly on this dotted line? They would match up, wouldn't they? They would almost come like they would lie right on top of each other. If two things are inverses, we know that they reflect across the line y equals x. So there's two things I'd like you to note down here. They reflect across the line y equals x. And the second, I'll allow you to put in your own words and give you a little bit of time. Remember that the x values of the original function become the y values. Once again, the x values of the original function become the y values of the inverse, and the y values of the original function become the x values of the inverse. I'll let you put that into your own words for part D.